Hello, Algebra 2, and welcome to Lesson 6.4 on logarithms and logarithmic functions. Go ahead and pause your screen and try this warm-up. This warm-up is actually over Section 6.2 and solving exponential equations and inequalities by changing the bases. Okay, number 1 is x equals 1/2. I would use a base of 4 for both of those. You could also use a base of 2. Number 2, I would change this one to 2 to the third, and you would end up with x equals 6. Number 7, x is less than 5. Number 4, x is greater than or equal to negative 2 using powers of 3. Number 5, $15,613.98. And number 6, $393,891.35. So before we found inverses of functions, now we're going to evaluate and graph logarithms. There's a lot to cover in this section, so I'm going to go pretty quickly through it. I'm not going to read the problems. Feel free to pause this at any time should you need more time. So definitions, a logarithmic function. So an exponential function would be like this blue one here, 2 to the x, which we've looked at it before. Inverses are reflected over the line y equals x. So if this is the exponential function 2 to the x, this is the logarithmic function, if you will, x equals 2 to the y. The inverse of y equals b to the x is x equals b to the y. The variable y is called the logarithm of x. It's usually written as y equals log base b of x. So you can see here how the x's and y's switch places, and you can see graphically what it looks like. A logarithmic function is a graph of a log. The base can change. You see this little b right here? That could be any different number. We'll talk about the different bases as we go through. So here's the key concept of a logarithm. Log base b of x equals y if and only if b to the y equals x. b to the y equals x. So if log base 3 of 27 equals y, then that means 3 to the y equals 27. The inverse of an exponential function, a function with x in the exponent, is a logarithmic function. Just like you have addition and subtraction, multiplication and division, you have logarithms and exponents. To undo an exponential function, you change it to logarithmic form. To undo a logarithmic function, you change it to exponential form. So this is logarithmic form and this is exponential form. Log base b of x equals a implies that b to the a equals x. And to me, it's all about this motion. The base to whatever's on the other side of the equation equals the argument or whatever you're taking the log of. B to the a equals x. For example, let's change these to logarithmic form. Using the pattern, that would say 5 to the second equals 25. Number 2, 5 to the third equals 125. And number 3, 2 to the negative 3 equals 1 over 8. All of those are true statements. So let's write this one in exponential form. 3 to the second equals 9. In letter B, 10 to the negative 2 equals 1 over 100. Doesn't matter which side it's on. So you go ahead and try these ones. Write this in exponential form. Letter B. Write this one in exponential form. Letter C. So now we're going to write one in logarithmic form. This is in exponential form. So what I do is I just kind of deconstruct it. It still has to say 5 to the third equals 125. Okay, try this one. So the base would be, base of the exponent is the base of the log. So log base 27 of 3 equals 1/3. 27 to the 1/3 equals 3. So go ahead and write this in logarithmic form. Letter A. And write this one in logarithmic form. Letter D. Okay, let's evaluate a logarithm we don't know the answer for. What's log base 3 of 81? Well, log base 3 of 81 equals something. We don't know what it is. Let's change it to exponential form. So 3 to the whatever this is equals 81. Do you know what power of 3 is 81? Well, 81 is 3 to the 4th. And if 3 to the 4th equals 3 to the y, that means y equals 4. So log base 3 of 81 equals 4. Try log base 10 of 1,000. 10 to what power is 1,000? And the answer is B. Okay, now we're going to turn our attention to the graphs of logarithmic functions. The parent function would just be log with any base of x, and this is what it's generally going to look like. It's always going to go through the point 1, 0, because log of 1 is 0. It's always going to go through b1, because the log of this base is going to be 1, and 1 over b, negative 1. The domain, and there's a different, if the base happens to be less than 1, but this is a continuous one-to-one graph. The domain is x is greater than 0. The range is actually all real numbers. It goes all the way down, and this will go all the way up to infinity. Asymptote is the y-axis. There's an asymptote at x equals 0. There's an x-intercept at 1, 0. There is no y-intercept. There is no symmetry, and there is no extreme values in the graphs of logarithms. So just so you can get used to the shape. And using that, let's see if we can graph log base 3 of x. Feel free to use your calculator to help you out. Identify the base. The base is 3 of this particular logarithm. So determine the points on the graph. Using this information, we know it's going to have 1 over b negative 1, 1, 0, and b 1. So let's just replace b with 3. That's going to be 1/3 negative 1, 1, 0, and 3, 1. Put those points on the graph and go ahead and connect the line in this basic shape. Let's graph log of base 1/4 of x. So what's the base? The base is 1/4. So again, there are 3 points on the graph. It's going to be 1/4, 1, following this one because 1/4 is between 0 and 1, 1, 0, and 4, negative 1. And then you can sketch the graph and draw the shape with some help from the key concept. Okay, which one is the graph of log base 5 of x? That is D. And which one is the graph of log base 1/2 of x? That is A. So once we understand the graphs of these logarithmic functions, we can now form them like we have other functions. Multiplying by A changes the orientation and shape, stretching vertically, compressing vertically, or reflecting across the axis. H shifts left or right. Remember, if it's in parentheses, it's the opposite of what you think. H minus moves to the right, H plus moves to the left. And then K is what you think it was, is after the parentheses, shifts up and down. So using this information, we can now graph some more logarithms. 1/3 log base 6 of x minus 1. A is 1/3, so we know the graph is compressed vertically. There is no h value. There's nothing in parentheses, so there's no horizontal shift. And k equals negative 1, so we know it's been shifted down by 1 unit. Then we can just take our points that we knew, multiply them by 1/3, and graph them. And again, we can use our calculator for assistance. Let's try this one. So we know that we have a log of 1/3 of x. 4 means it's been stretched vertically. H is negative 2, so that means it's been translated 2 units to the left. There is no k value, and then we can sketch the function based on our knowledge of the transformations. Again, you feel free to use your calculator for support. So one's for you to try. See if you can match the graph of this function. Letter B. And see if you can match the graph of this function. And that is letter D. Okay, real world example. Go ahead and pause this and read it if you want to, but they give you an equation. We have a pressure of about 20%. So here's the original equation. We're going to substitute 8 for x, and we get 0.168 atmospheres. Not too difficult when they give us the equation, but let's see what part B is. We're going to write an equation for the inverse of this function. Well, if this is our original equation, we can switch x and y, or x and p in this case, and then we can change it into a logarithm, into logarithmic form from exponential form, giving us our inverse function. So one for you to try, see if you can answer this question. Letter B and letter D. That does it for 6.4. Whenever you are looking at your assignment in 6.4, there are two parts for 6.4. 6.41, here's your warm-up on the asteroid strike. Then there's some notes which should look pretty familiar, some examples, some more examples, and then some more examples, and here's some problems to try, 18 exercises, and then an exit slip. And then you do not have to do the enrichment. You are welcome to, but you do not have to. And then when you get to 6.4 part 2, they're going to talk about logarithms and exponents. And I think here's your warm-up. Here we're focusing more on the graphs, the same thing we just did in the lesson. Some very similar examples. And then real-world examples. And lastly, here are your exercises where you're graphing each function. Feel free to use your calculator to help you out. And again, you do not have to do, you should do the exit slip, but you do not have to do the enrichment. And of course, don't forget to complete the weekly quiz as your last assignment for the year. I hope all is well. I'll see you soon, everybody. It's been fun.